Aloha, this is ITS128, and today is November 10th, and let me share my screen. And 128, and we are in this week. No, we're not. We're in this week, although we are finishing up these labs, actually 24 through 28 today. So let me open up just in case anybody has anything to chat about. All right, let me move this over here. Okay, so let's just go through these, and I'm going to try to, talk through my thoughts to help you see how the mind, or at least how my mind works as I'm walking through these problems. So let's start with 624, convert to binary numbers. So what this is going to take a positive integer, and then it's going to output a string of ones and zeros that represent the binary number. So first of all, let's just make it easy to give us some test data of binary numbers. Is there some kind of table or something? Well, anyway, this probably gives some examples here. Oh, yeah, okay. Anyway, binary numbers are base 2, and when you count in base 10, the numbers go all the way up to, there's 10 digits, and 0 through 9, and then once you get to the last one, you start over again, but you add 1 to the position to the right, to the left. With counting in binary, it's exactly the same thing, except for you only have 2 digits. So when you get to the 1, you're at the top already, and then you got to go to 1, 0, and so on. So the algorithm for converting is this right here, and the way it works is you input some number x, and then you keep on doing this modulo operation on x. You do the modulo operation on x, and you're going to get either a 0 or a 1, and that's the binary digit. And you store that away, and then you subtract off the binary digit you just discovered, basically, or you do an integer divide by 2, and then that's your new x. And each time you go through the loop, x is going to get smaller until it gets down to 0, and then that's when you're done. So for example, here we have 6, and let me just open up the whiteboard, and let's go through this algorithm with the whiteboard with 6. And so I've got 6, and so 6 is 6 greater than 0? Yes. So output x mod 2, 6 mod 2. Well, 6 mod 2 is the remainder of 6 divided by 2, and so that equals 0. So I'm going to put a 0 over here. So that's the first digit. And then I take the integer, I do integer divide of 6 divided by 2, and that gives me 3. So now x is equal to 3. This is x right here. And what's the remainder? Okay, and then we go back up to here. Is 3 greater than 0? Yes, it is. So what's the remainder of 3 divided by 2? Well, it's 1. So this is the next digit, and I'm going to put that here. And then we take the integer divide of 3 divided by 2, and that's going to give you 1 with a remainder of 1, but we only take the integer part of it. So it's 1. And then we go back up here. Is 1 greater than 0? Yes, it is. And so then we output 1 mod 2 is 1. So the last digit is going to be 1. And then when we take 1 integer divide 2, we get 0. So and then we go back up here, and x is no longer greater than 0. So we're done. So this is the string of digits. Well, the trouble is 0, 1, 1 is actually the reverse of what we want. We actually want 1, 1, 0. That's the problem. When we're collecting these digits, we do each time we're getting the next lowest order digit. But the trouble is now what we could do is when we create the string, instead of attaching the next digit onto the end, we could attach the next digit onto the beginning. Okay, that's one way of solving this problem, but that's not the way they would like us to solve it. They would like us to make one function that figures out what the integer value or what the reverse binary string is of the integer value. In other words, first we figure out this thing, and then we take that and we convert 0, 1, 1 to 1, 1, 0. And the way we convert 0, 1, 1 to 1, 1, 0 is we basically can just start at the end, and we start at the end, and we take the last one and we put that here, and then we go to the next to the last one, and we take that one and we put that here, and then we take the next one until we get all the way down to 0. So this is like 0, 1, 2. We start out at 2, then we take the 1 and we take the 0s. So we traverse through this string of 1s and 0s. We start at the bottom and go up, and as we go up, we create a new string, which is the reverse, which ends up being the reverse. So so that's what they would like us to do. So let's start by writing some code. Let's go here, and we're going to have to make these two functions. Okay, so I'm just going to copy this. I'm going to copy here. This is what we start with. And so there's going to be one function here, and then there's going to be another function here. And then what we're going to want to do is to test the code. We're going to have this thing here, and we're going to put our code there. And our code is going to be something like, some sort of integer. I'm going to call it I'm just going to call it num for number, int num, integer number. Okay, equals here we call it integer. Okay, integer number equals integer of input of integer. And so what this does is this asks you to enter an integer, and then you're going to enter the integer, and then then this function is going to work, the int function, that'll convert it into an actual number value representation inside the computer, and it's going to store it in this variable right there. And then we're going to want to take the reverse of it. So we're going to want to find the reverse binary, so we can say reverse binary equals integer to reverse binary of integer number. And so this function, which we're going to write, is going to reverse the just a minute, I just want to make sure, yes, I'm recording. Is going to return this thing. It's going to return this thing here, and then we're going to, and that's going to be stored there, and then we're going to plug that into this function here, and binary number string, because it's actually a string, is equal to reverse string of reverse binary. now I'm trying to be very descriptive with the variable names here, just so you can sort of see what's going on. And so this is that, and then this is what I'm going to output. So output print binary string, number string. Okay. By the way, you might wonder, all of a sudden this has popped up, and I haven't been going through the textbook page by page, and I sort of did a cursory search to figure out where it talked about this. I never really found it. So I searched the web, and in fact, if you want, actually what I did was I did this. What is that? Put quotes around it. What is this? Okay. And it comes up with this Python description saying what it's good for. And basically what it is it makes sure that when this code executes, that it is being called by the main program, because you might make this program like this, and then you want to just use that as a module, and in some other program that you have, you want to import this module, and then you want to just use the functions inside this module, and you don't ever really want this code to execute. The only time you want that code to execute is when you're executing this module as your main module. So this is just protection to put up at the top in case you're coming along here now and writing these functions, and you may want to just use the code here, and this way you don't have to worry about when you're importing the module that this code just executes, and you're running your stuff and that code's executing, and you're wondering where this code is coming from, or where this output is coming from. So that's why we're now just routinely putting that up there, making sure that this only executes if this is the main module that is asking this code to execute. All right, so so this is the main code that goes out here. So all we need to do now is write our functions. So I'm just gonna start with I'm gonna write code to sort of debug these functions separately, and then you can put it together. Okay, so I'm going to start by writing the code to execute reverse string, and so I can do this by, let's see. First of all, I'm just going to do this. I'm going to say this is supposed to return an integer binary. I'm just going to say return 11111 or something. It doesn't matter. This is going to integer. Yeah, so it's going to reverse. It's going to return a string based on this. I want to debug this though. So so it's a string, and I want to return the reverse of that string, one character at a time. So I'm going to assume that this is actually a string. Okay, so I'll assume that's a string. And then I want to go one character at a time, but in reverse order. So I can do something like this. For some index value, I'm going to use the variable I, in the range of, I want to go from the top of the string down to the bottom of the string. So I want to do, and I'm going to be referencing using I each character at a time. So we're going to start at the length of input string. I hate it when that happens. The length of the input string down to 0, -1 at a time. So it's going to start, so I is going to start at the length of the input string, and it's going to go down to 0. It's not going to go all the way down to 0. It's going to go down to just before 0. So actually, if the string is 1, 2, 3, 4, 5, or let's say it's A, B, C, D, E, A is actually the 0th element, and there's actually, and D is A, B, C, D, E. E is actually the 4th element, not the 5th element. So this I is actually 1 off. This I is going to go 5, 4, 3, 2, 1 instead of 4, 3, 2, 1, 0. Okay, so we have to keep that in mind when we're writing our code. And then I'm going to start a new string. I'm going to call it the return string, because I have to have a variable here to as I concatenate on the thing. Okay, so make this like this, and I'm just going to go return string, and I'm going to append onto that, concatenate input string, and it's not I, it's I minus 1. Okay, so remember if let's do if A, no, let's do a 1, 2, 3, 4, 5 is the string. This is actually, the 4th index number 4, and this is index number 0. See, that's my point. So this is gonna this will reference the correct character. I think you get that. Okay, so now I'm just going to return this. Okay, so I'm going to do reverse binary. Forget this here. Okay, you got all this, right? I'm going to do string. And I'm going to call it this. Go to this. Oh no. This is going to be sum string, and I want to do this sum string, and I'm going to reverse that, and it's going to be this one. It's going to be reversed string. Okay, so this is going to enter a string. Then it's going to call this reverse string function, which is this thing, and this thing should do the reverse thing. Okay, which is so if it's it should make it, if we have A, B, C, D, E, it should start by creating a return string. Is going to equal, first it's going to equal E, then it's going to equal D, then it's going to equal C, then it's going to equal B, then it's going to equal A. Okay. So let's save this and run it. Python test.py, reverse string, sum string, use of tabs, inconsistent use of tabs. Well, we know what that is because I haven't set up my editor properly, because you've got spaces. So 3, 1, 2, what is this? 4, 1, 2, 3, 4. Is that right? Oh no, it's too much. All right. Let's just put them all in again. I gotta set up my editor. So I'm going to send this in once, this in dunt, 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 dunt. Oh, I want to do that. Oh, I don't think I did this right. All right. Sorry for wasting so much time. Sorry for wasting time. Okay. SORRY, FOR, wasting time. Okay, that works. And now the other thing is that we want to get this thing to work. So I'm going to just do some integer, input an integer, and I'm going to do integer to the reverse, this on here, and this is going to be reverse binary, and I'm going to print reverse binary. Okay, so I'm going to basically write this. Okay, so they give us the algorithm. Let's go check out this algorithm here. I'm just going to copy this. It's going to look something like that. Excuse me. I'm going to go like this and paste that there. And that's going to end up being something. So I'm going to say we have an X. That's actually X. I'm going to call it X. X. And I'm going to say while. Now this looks like while X is greater than 0. While X is greater than 0. While that. Then what? Oh, output. Well, I don't want to output. I'm going to create a string, attach a string. So I'm going to go, some string is a return string equals dit, okay? And while X is greater than 0, return string equals plus equals, and I got to make sure this is a string, so I'm going to str that. Yeah, that should do it. X mod 2, take the string of that and concatenate that onto the end of return string, and then I got to do this. I got to make X equals X mod 2. I mean, integer divide 2. Let's see if that does it. Oh, I got to return that. Then after that, I got to return it. Okay. So I'm going to save this, and I'm going to do run this again. Enter an integer. I'm going to 6. What happened? X is not supported. Oh. This is not. This should be an integer. It's an integer. Oh, it is an integer. I've got to say that it's an integer. Int. Now it's an integer. Before it wasn't. Okay, let's try this again. 6. 0, 1, 1. Okay, that's the reverse of this. Let's do, let's see, 31 is 1, 1, 1, 1, 1. So 24 is, well, let's just see what it is. 24. Yes, it's actually 1, 1, 0, 0, 0 because it's 16 plus 8 plus, okay, so but really we want the reverse. Okay, so anyway, so this thing works. Okay, Now you know both of the functions that you need, and you can put those together just like I did in the beginning to see that it works. But I'm going to try one more thing, okay? I'm going to see if we can bypass this reverse string thing. Now, this isn't part of the assignment, okay? This is just my curiosity. And I'm going to say this. Return string equals that plus return string. And I'm going to see what ends up being returned here. Save this. And if I enter 24, oh, look, it returns it in the right order. What if I do 6? Oh, okay, it works. Anyway, so that's, I think I've given you more than you need to know to do 6.24. What's next? Swapping variables. All right, this silly assignment is just a really dumb assignment, because we're supposed to write this function that where you take in two variables, whatever, integers, I guess, and you want to return them in reverse. Okay, so basically you read in a 3 and an 8, and it returns an 8 and then a 3. Okay, and what they want you to use, the function that they want you to use, is the fact that this thing is really, you want to return user val 2 comma user val 1, and see, you're returning two values. You have a function that returns two values. Okay, that's okay. The other thing about this is that you can just do this. You can just say, let's say input. No, let's say val 1 equals input first. I'm just going to do this. And val 2 equals input second. And okay, so you got that. Now you can just do this. Val 2 comma val 1 equals val 1 comma val 2. Okay, so you can do that. And you can say print val 1 val 2. See, I think this works. First one is 1, 2, 3, 2, whatever. That's the first value, and the second value is this value. And now it's going to print out, the reverse. So with Python, you can do this. Okay, I don't know of any other language where you can do that. Okay, this has got two values on the left-hand side of the equal sign and two values on the right-hand side of the equal sign, and there's just like a 1-for-1 replacement or a 1-for-1 assignment. See, so this gets the first one, this gets the second one, and also it does it in a way where it doesn't write over the first, like okay, the first, val 2 gets this value, but when we get to here, it's still what the first one was. Okay, so this doesn't overwrite this, and then this is now equal to val 1. Okay, it actually does it where, before the assignment started, then after the assignment started. So now, for you to actually do this on a computer or on a microprocessor, you have to have that temporary variable thing. Okay, that you can't do it really any other way. When this thing compiles down to bytecode, you remember we talked about bytecode a few classes ago? There actually is a temporary variable that comes into play here. But anyway, this is kind of a dumb assignment, because really sometime or another we're going to learn this. So HL sent me a good question here. So this is his question. So I'm going to copy over all the code here. Let's see. Let me just copy this over here. You know, this is good. When you guys ask questions, it's really good because you ask things that I don't even think about that could go on inside your mind. You know, so let me just so let's look at this code here. I'm gonna just kind of do something like this. So it works. All right. So Mr. Liu asked why this doesn't work. This code does not work in Zybooks. Okay, now if you're asking like you copied this right into Zybooks, okay, so you're saying why it doesn't work. Now, does it print? This code prints out the answer in the function, and you're supposed to print out. You want to print out the answer in the main program. So you really do want something like A comma B equals that. And this is going to return two values. So you don't want to have this up here. You would want to have that down here, like right there. I'm not going to paste it back in there because I'm giving away the answer, giving other people your answer. But yeah, you do want to have, you can just do this, 2 comma 1. That's what I do. And then this is gonna swap the values just fine. And then this is going to return the swapped values, and then this is going to, I'm going to give away the answer here. Let me see. Let's see if this works. Develop mode. I'm supposed to put something in here. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Oh, that's a thing, and this is a thing. Cool. All right. Spent too much time on that one. All right, exact change. Okay, in this one, we are we enter in some number. We read in some number, and there's a bunch of things. There's a bunch of checks. You got to check to see if it's 0, because if it's 0, you're going to put no change or whatever. But anyway, assuming you get a regular number, you're supposed to say what the coin types and number that are going to be returned, or that converts to, like the coinage, I guess. Or, you know, let's say you're the clerk and you got to hand back the change, and you got to hand back 45 cents. What do you give the person? You don't give them 45 pennies. You probably don't give them 4 dimes and a nickel. unless you don't have any quarters. What you do is you want to give them the most of the highest one, and then on down, so that you end up giving them the fewest number of coins. Okay, and so so the way to do this is to start by taking, you know, you start by dividing out the quarters, dividing out how many quarters you can give the person. You get some, then you get a remainder, and then you divide out the dimes, and that's how many dimes you give them, and then you get a remainder, and then you divide out the nickels and get a remainder, and then what's left is going to be the remainder of dividing out by nickels is going to be some number between 0 and 4, right? Because if it was 5, it would be another nickel. So so that's how you go. And what they want you to do is they want you to write a function called exact change that is going to return, yeah, see here, it's going to return 1, 2, 3, 4, 5 numbers. It's going to return 5 numbers. And the first number is going to be the number of dollars. And the second number is going to be the number of quarters, and then the number of dimes, and the number of nickels, and the number of pennies. And so then what you need to do is print out something that looks like this. Now, in your printout, your printout's got to be smart enough where if it's 0 dimes, you don't print anything about dimes. Okay, so it might be $0, you know, 2 quarters, 0 dimes, 1 nickel, and 3 pennies. Okay, so that would be like 53 cents or something. Okay, so you can't, so since there's no dimes, or since there's no quarters or whatever, you don't print anything about that. So you're not going to print, you know, 0 nickels, 0 pennies. Okay, so that's being smart in how you print it out. I'm not going to do that. You should be able to do that. What I'm going to work on is this function here. Okay, and so this function is going to print out some 5 numbers, and each of them is going to be, one's going to be the number of dollars, it might be 0, and so on. So let's write this exact function, exact change function. So I'm going to do definition of exact change, and it's going to be some input number, some input value or something, some value. Some amount. Okay, how's that? And okay, so I might as well just shoots. I'm gonna say dollars equals 0. Yeah, quarters equals 0. Dimes equals 0. Nickels equals 0, and pennies equals 0. Oh, you also have to be smart enough down here where if it says like 1 penny, you say 1 penny. If it's 3 pennies, you say 3 pennies. And so pennies is different than penny. Okay, I think we had another assignment like this earlier in the semester, if I'm not mistaken, and you sort of should have been able to figure that out. But it's just another if statement. You know, you got to have there's a bunch of if statements in this, and some of them are if the value is 0, or it's only if the value is greater than 0 do you do something, and then also if the value is just 1, you write something out. If the value is more than 1, then you write something else out. So okay, so the first one is dollars. So we're going to say, so first we're going to divide out the number of dollars. So that's just a dollars equals amount, integer divide 100, because it's actually in pennies. So the amount is 542. 542 is actually 542 pennies, but really it breaks out to $5 bills, and then you got 42 cents, and then see, it's 3:55. I think I got time. Let's say it's 4:37. Okay, so first you divide out the amount is equal to this. So first let's do dollars. Dollars is equal to a double divide 100. And so what this is going to do is D is going to equal 4. Yeah, because if you divide 437 by 100, you get 4 plus a remainder. But we're ignoring the remainder, okay? But now we want to subtract out 400 because we only have 37 left. How do you get 37 left? Let me do this. You can do A equals A mod 100. Ooh, that's not what the solution is, but this is better. So now A is equal to 37. And now, so this is the dollars, and now we're going to do quarters. So quarters equals A dividing out 25. And so that's going to be just 1 equals 1. And then we have A equals A mod 25. And that's going to equal 12, right? Yeah, 12. 37 divided by 25 is 1 with a remainder of 37 minus 25 is 12. So now A is equal to 12. And so that's quarters, and then we're going to do dimes. Dimes equals A double divide 10, and that's going to equal 1. And anyway, and so on. So so you get the idea. Let's write the code then. So dollars equals amount, divide that. And so we have a dollars amount, and then we're going to do amount equals amount mod 100. And then we're going to do quarters equals amount integer divide 25. And then amount equals amount mod 25. Dimes equals amount integer divide 10. Amount equals amount mod 10. Nickels equals amount integer divide 5, and then amount equals amount mod 5. And that's what pennies is. So this is going to be the pennies. Pennies equals amount. Now we can say integer divide 1, but it's just amount. Okay, so that looks like that's the answer. And then we're going to return dollars, quarters, dimes, nickels, pennies. So if I do this, print, this is going to be fancy. Will this work? I don't know if this will work. Print input integer amount equals input integer input, enter a amount, enter an amount. Okay, and then I'm going to say, I better do it this way. This is equal to exact change amount. And then I can say print that. I'm going to say, well, I'll just do this. Okay, let's see if it works. Enter amount. What did I say before? 437 or something like that? Oh, 553, whatever. 537. So it's 5 $1 bills, or $5. 1 quarter, that brings up to 525. 1 dime brings up to 535. Nothing there. And 2 pennies brings up to 537. Okay, so your code then has to take each of these, and it's got to say, you know, something like if dollars is greater, you know, if dollars is equal to 1, print dollars, dollars. Yeah, I don't know, to the space. No, dollar. If it's equal to 1, if dollars is greater than 1, then I would print dollars, comma, dollars, because it's plural. Otherwise, I don't do anything. Otherwise, I go on to quarters. If quarters something like that. So I'm just going to run this and see what this looks like. Enter amount, 437. Yeah, see, $1 for quarter. 4 quarters. Yeah, that's better. 237. $2 1 quarter. Okay, anyway, so you should have enough to do that one. What's next? All right, even, odd values in a list. Okay, so here's what you do. You read in, you read in this list, and you're supposed to say whether the list contains all even numbers, or if the list contains all odd numbers, or the list contains a mixture, or neither all even nor all odd. It equals a mixture of them. And we're not going to use a sentinel value. We're going to first input how many numbers to expect, and then it's going to then you enter in the numbers. Then it's going to print out whether it's all even, or it's going to say all odd, or it's going to say not odd or even. Some would say nor, but okay. So I can do one of them. I'll do one of them, but I won't do the other one. So first of all, so I don't think I have to read in all the numbers and then go back. I can just keep track of these as they come in. Okay. Am I supposed to write a function? Oh, I'm supposed to write a function. Oh, so I have to pass it a list. All right. Do I need to? Yeah. All right. So let's do. I have to first read in this list. So let me do this part first. So I'm going to read in a list here, and I'm going to do. First I got to read in how many I'm going to read in, right? Num in list equals some integer value that I'm inputting, something like how many in your list. Does that work? Yeah, okay. How many in your list? And then I'm going to do for doesn't matter. For I in range of num in list, do something. And what I'm going to do is I'm going to input a number, I'm going to input a number, input, enter number. And I'm going to append this to this list. I got to create a list somehow. Do I just start using a list? No, my list. Got to do something like this to declare it. It's like an array. And I'm going to go my list, append, I think that's right, whatever num is. Okay, so when I'm all done with this, I got this my list, and now I can say if is list even, I'll do even, my list. If it's true that the list is even, I don't think I need parentheses around here, do I? I think I do. If the list is even, then print list is even. Otherwise, I'm going to print list is not even. Okay, and with this getting this to work, you should be able to get the rest of it to work. So I got to write a function, def is list even, and I'm going to pass in some list, passed list, whatever. And I got this list here, and I got to go all the way through, starting at the beginning, and look at each number. And as long as the numbers are even, it's okay. But once I get a number that's not even, then I know the list is not all even. Yeah, and I'm only checking even. I'm not checking if odd. Okay, that's another function that checks odd. Okay, I only have one mission here, and that's to see if all the numbers are even. So I start looking, and okay. List is even, and I'm going to say that's true. Start out by saying it's true, and then I'm going to do for item in, I'm using index again, if in range length of pass list, I think that's right, in the range of the length of the pass list, if pass list of I minus 1, because it goes from 0, no, that's right, no, just I starts at 0, goes up to the length 1 less than the list. If that is mod 2, if the number, that element, this is an element. If that particular element in the list, mod 2 is 0, no, is 1, equals 1, then we know that the list is not all even. List is even equals false. Now, right here, we should be able to exit out, right? Yes. And how do you, what's the exit word? Is it exit or is it break? Anybody know? Break, exit from loop in Python is break. Okay, still need to do that. Break. I just say break, right? I just say break. So I'm going to say break. Okay, and then so now I'm outside the loop, and I just return a list is even. Okay, so if list is even, or if it starts out being even, and if it goes all the way through all the numbers in the list, and this is never true. In other words, when we take the element and we do mod 2, and it's never equal to 1, in other words, it's always equal to 0, then that must be an even number, and we just keep on going. If we get all the way to the end and we get down to here, then we know that the list is and the list is even is still true. Then we know that the list is all even. All the digits, all the numbers in the list are even. Now, we don't have to have this break, and all that means is that we go all the way to the end. But the first time it gets a number that's not even, it's going to set that list as even equal to false, and it'll just stay false all the way through. But it'll keep on looking at the rest of the numbers, even though it doesn't have to, because it already knows it's not even. But we just put the break in there just to save a little bit of time in case that first odd number is early on in the list. And we save some time there. We don't have to go all the way through the list. So anyway, let's see if this works. I know why, is because it's just one. Yes, how many in your list? 5. Enter a number. What were some numbers? Some numbers. 1, 2, 3. Oh, 1, 2, 3, 4, 5. Oh, 1, 2, 3, 4, 5. It's not even. Okay, let's try this again. 5 numbers. Let's do 2, 4, 6, 8, 10, 20. It's all even. So anyway, so that's that. Okay, so you should be able to figure out how to do the rest of this problem. All right, what's next? Output values in a list below a user-defined amount function. Okay, so, all right, great. What this one is do you guys ever get these on your phone? It's like, of course I'm not going to answer this. Oh gosh. Okay, so this one's a little different. Okay, and this one, yes.
Sorry about the last question, 627. In the book, the first input it says 5, 2, 4, 6, 8, 10, and the output it says all even. How come we have 5 in the numbers?
Oh, well, that is because the first number says how many numbers you're going to enter in.
Oh.
So we're going to enter in 5 numbers, and then here they are. There's the first one, the second one, third one, fourth one, fifth one.
Okay, sorry. Thank you.
Yeah, I don't know why they don't use sentinel values to say, enter in the list until you get a -1, then you're done, and then you don't have, and let the computer, add up how many are in your list. Why do you have to add up how many are in your list? And then you tell the computer, and then the computer says, okay, anyway. But there are many times when, of course, the number in your list, and if it deviates from that number, there's something wrong. So instead, what you would do is you'd have a check in there to see if you entered in more than 1 or whatever. All right. So anyway, so this last one here, again, we're going to read in all the numbers into a list, but then like this one, 5 numbers, and here's the 5 we're going to read in, and then what we're going to do is we're going to read in one last number. And then we're going to go back to the list, go all the way through, and then we're supposed to print out all the numbers that are less than or equal to that last number. So in this case, it's going to be 5 numbers. There they are. And then we print out, after we read in the whole list, how many print out the numbers that are less than or equal to this 100. And that would be the 50, the 60, not this one, and the 75. And so it prints out 50, 60, 75. Okay, so it's very similar to the one we just did here. So I'm gonna just leave this here. I'm gonna get lazy. I'm gonna be lazy. And I'm gonna, does it tell me what to get user values? Oh, it wants you to write a program to get the user values. Well, that would be something like def get user values. And let's just make it be this. Something like this. And return my list. Yeah, my list. Okay. And I'm going to do this. Enter number. Enter number 1. Can I do this? Will that work? It might work. All right, so that's that. And this is just going to be oh, this gets everything. First it gets, and then we go enter threshold equals integer input enter threshold value. And we want to return 2 things. We want to return the user values and the upper threshold. So it should be, we want to return the user values plus the threshold. So that's what we are returning. So let's get rid of this garbage. I'm just gonna go like this. I'm just gonna put this code here. I'm gonna tabify all this. There we go. So this is that. And then we got another one. Oh boy. Oh gosh, they gotta be so verbal. User val, I might as well just do this. Values, vals, thresh. There, how's that? Oh, so this is my list. And this is the threshold value. And so then I go through the list. Wait a second, I'm going to make things easier for myself here. This is called past list. And this is called, I'm outputting a list, are I not? So return list equals dun dun. So I go through all the past list, and if the past list number is less than or equal to the thresh, then I'm going to append return list append past list the value. Append that on there. And I'll do that. And what am I returning? I'm returning, all of the, wait a minute. This thing prints it out. Oh, so I'm not returning anything. I'm printing them out. So I don't have to create a list. I'm just going to print them out. Really? I guess. Oh, yeah, I just print them out. Okay, so I don't need to make a list. I'm going to do more work than I need to. And I don't need to append anything onto nothing. Oh, what is this? Oh, no. Okay. Don't wreck that. I don't want to wreck that code. Past list for, no, I don't need to return. I'm not returning a list. I'm just going to print them out as I get them. If it's that, I'm going to print. There we go. And that's it. Pow. Okay, so this little function here, it prints out, you pass in a list, goes through all of the elements of the list, one at a time, from 0 on to length of past list minus 1. And if any one of them is less than or equal to the threshold, the passed in threshold, that's this thing, then it prints it out. Otherwise, it doesn't print it out. So let's try this. No, I'm not going to try it. I'll leave it for you to see. I'm pretty sure this will work, though. All right, is that okay? And if you have problems, just, you know how to get a hold of me. All right, so I guess I don't have any more. Does anybody have any additional questions, last questions? I think that takes care of everything. Oh, by the way, I uploaded your grades. Okay, I uploaded your grades. I actually have this program where I download the grades from Zybooks and I paste it in this thing and it converts it into La Lima format and upload the La Lima format. And I just did that about like an hour before this class. So go in there, and if there's anything you disagree with, just let me know and we'll fix it. Also, remember that if you missed, see, I think I did all the way up to chapter 6, all the way up through chapter 6. So a lot of you might not even be done with chapter 6, obviously, because I just did this today. Or any of the previous chapters, even chapter 1. If there's something you didn't get to in any of the previous chapters, it's okay, because the next time I do the grades, I'm going to go back to the very beginning again, just like I did this time. So, so anything all the way back to chapter 1 should be updated. All right. And it doesn't look like anybody dropped, at least from the last time I did the grades, which is very good because you know, I like to get everybody through, and only having to pay once. Okay, so if you and the grade that you want too. So I know sometimes it's better to get a lower grade. I remember when I was I had been through about, okay, it took me like 6 years to graduate from college, and so because I was a bad student, and but at the very end, I decided I wanted to go to graduate school, and so and where I went to school, I was in electrical engineering school, and you had to get a 2.8 average. It's the grade. They're really tough graders back then. This was back in the 70s, and you had to have a 2.8 average to get into graduate school. And I didn't have a 2.8 average. I had lower than 2.8 average. They gave a lot of C's back then, and I started taking classes, and I took about like another year's worth of classes, and I had to get an A, or sometimes I could tolerate some B's, but I needed A's because I needed to get my GPA up. And if I was going to get a C or lower, I would ask the professor to give me a non-passing grade, because back then where I went, the University of Minnesota, this was a big deal back then because they quit doing it. Now I think they're back doing it again. But they didn't count on your external transcript. They didn't count grades that you didn't pass. So if you had W's or you had F's, those didn't show up on your transcript. So that's a time when you actually might want a lower grade. Anyway, I know that can happen too. And I think it's really good that these days they let you take classes, more than once, and your highest grade is your highest grade or the last grade, which should be higher than the previous grades, is the only one that sticks. And I agree with that. There were classes that I took more than once, and there were classes where I handed stuff in late. But I have knowledge in my head, and I don't remember. It doesn't matter if that knowledge came after the due date of the assignment and I didn't get as many points on it, or that knowledge came after the second time I took the class rather than the first time I took the class. The fact of the matter is I have that knowledge in my head now, and I'm good at using it. And so that's how it should be. And I'm glad that grades now are much more reflective of what you know and not not how well you managed your time when you were a lot younger. So anyway, are there any more questions? I think we're done with chapter 6. And starting Thursday, we'll start with chapter 7, strings. All right. Didn't take a shower this morning. I didn't want to show you my bed head. So I will see you. It's 4:27. I will see you next Thursday, on this coming Thursday. It's holiday tomorrow. So take care.
Thank you.